At the start of each year, apparently I invest $1,000 in my superannuation fund. Okay, stop right there. Superannuation. What does it mean? Well, from the name of the thing itself, you can already tell, annuation. It's something that you do every year. So this is why, just to make it really clear, it says at the start of each year, just in case you didn't notice that, right? Now, what is the super in superannuation? Well, I keep on adding money in, and I'm actually required by law not to take it out. So it's like the ultimate investment. I just throw money in there, and hopefully by the time I retire, it's nice and large, and I can use that. I can draw from those funds for the rest of my retirement. That's the theory anyway. That's what happens at the start of each year. At the end of each year, it gains interest. I'm handing this money over, they're putting it into like shares or something like that, and hopefully it grows. Question part 1. Find an expression for the amount in my account at the end of 3 years. Now, just to let you know, I've structured this just like an HSC question would do it. So these two parts, as you can see, are connected. This is the real question, part 2. We're going to use part 1 as kind of like a milestone to get there. Okay, so to begin with, just like I usually do, I'm going to write down the important pieces of information in the question, just so that I know which are the vital, details. So I've got $1,000, and that's at the beginning of the year. Please note that the question says beginning of year, end of year, so those things are different. And then I've got 5% interest. I probably should have put this in. It's per annum for this case if they haven't said anything, but they'll almost certainly tell you it's per year, it's per month, it's per quarter, whatever it happens to be. Okay, so I've written 5% per interest, and that's at the end of the year. Okay. So when they say find an expression for the amount in Mr. Wu's account at the end of 3 years, this question tends to be worth about 2 marks, and they want you to go through step by step and build what is happening here. Okay, so I'm going to say, this is my answer to part 1, let AN, and I'm using this subscript here because that's what we do in series and sequences notation. We mean, hey look, that's the nth amount, right? So let's let that be the amount in the account after n years, okay? After n years. So what happens after 1 year? Well, in the first year, I start off, it's January 1, I put $1,000 in, okay? But $1,000, while that's where I start, that's not what happens at the end of the year. I get interests. On December 31st, bam, they give me my 5%, okay? So what will I do to this to turn it into what it should be by the end of the year? I think multiplying by 1.05 is probably the easiest, most direct way to say it, okay? So there you go, interest applied, that's A1. Now I could go ahead and evaluate this number. It's $1,050, right? But because what I'm actually trying to do is get an expression for what's happening at the end of 3 years, I'm actually going to leave it expanded out like that because it will form a pattern. Watch. A2. I start off the second year with the amount I had before. So I'm literally going to say that, A1. But then what do I do? Well, January 1 ticks over, and what happens? January 1, I add in $1,000. I make a deposit, okay? And then the year passes, and then at the end, interest gets applied. Now, what does the interest get applied to? The whole thing, right? Everything in the account. So I'm going to put some big fat brackets there, and I'm going to say that multiplies by 1.05. Are you with me so far? Yes? So now I know what A1 is, by the way. It's 1,000 times 1.05 plus 1,000, and that gets multiplied by 1.05. You with me? Can you see a pattern starting to form? On the next line, I'm going to just expand out. This first number is the first $1,000 that I put into the bank at the beginning on January 1st, right? How many lots of interest have been applied to it? The 1.05 happens twice. Here the first time, and then here the second time. That's because that amount of money has been in there for 2 years. So it's got 2 lots of interest on it. Then there's this guy, and that's only got 1 lot of interest. Does that make sense? Because it's only been in there for a year. How are you going so far? Yeah. Yep. Now what's happening here? I'm forming a GP, aren't I? Right? Because I have this common ratio, and to get to the next term, I'm just going to multiply by that common ratio again. Let's do the last, in this case, the 3rd year, right? The last one. So A3 is going to be equal to, well, I start with A2. And then what happens on January 1st? I deposit $1,000. And then a year passes, and then on December 31st, interest gets applied. Now, I know it might feel a little bit long in the tooth to say it out like this, but you must understand what equation you're actually forming and know what all of these numbers mean, not just be able to write down the numbers, okay? So now I'm ready, I can put all this in. It is a find question, so you know what? The next one, I'm just going to write it like this. Okay, so just quickly before we move on, what is this first thing that I've written down? It's the first deposit I put in. Can you see why it's the first deposit? Do you see what's been applied to it? 3 lots of interest, because it's been in there for 3 years, yeah? This is the second lot I put in. It's been in there for 2 years. Here's the last lot. It's been from January 1 to December 31st, okay? I know it seems counterintuitive. It took me a long time to accept this, but if you had a single bank account with $1,000 in it, as compared to 1,000 bank accounts all with $1 in them, there's no advantage to putting them all in one big heap. They actually earn the same amount of interest all separately. So you could almost think of this one account as 3 separate accounts, each earning their own interest. Are you okay with that?